we can do insertion in three different ways. We can insert elements in end. We can insert elements at the head position, I mean in the starting position, and we can insert elements in the middle of the list. Okay, see what I mean to say is you can create a new node. So you can create a new node and insert at end. Okay, or you can create a new node, insert at begin. Okay, or you can create a new node and insert in the middle, means you have to link it like this. Okay, so this is, oh, I mean whenever you insert in the middle you will lose this link. So this is how we usually insert elements into a list. Okay, these three possibilities are there. So by the program, using a program, how could we insert elements in these three different ways? So I will take code segments to explain this, and step by step we will see. Inserting an element at end. See, you are inserting a new element in the last position. You are inserting a new element in the last position. Okay, so the process is same. The first thing is you have to create a new node. Okay, then what will we do? We will read a new value, right? And we will keep that value into the new node. These three steps are same, and this fourth step is also same, because you are putting that node at end. So new node next is equal to null, and new node next is equal to null means the created nodes next is null, and this last node is not last node now, because a new node is already created as a last node. So this should not be null, and this should have the address of the new node to establish link between new node and the current last node. Okay, so I write last next is equal to new node. This is last next, right? So I write last next is equal to new node to establish this link between a last node and a new node. Okay, and now what is the last node? A new node which is created recently is the last node. So last node is equal to new node. Now this last points to the new node. You can see that graphics here. See, after creating a new node, now this created node became the last node, and the end pointer part of the new node holds the null, because there are no further nodes, and the last node previously before inserting this will hold the address of the new node to establish link between new node and the existing list, right? So this is the code for what we can call inserting an element at end. Okay, now we will see how to insert an element at head position. Okay, so that is not that difficult, same as before. Okay, now see this. You have a list, 10, 20, 30, 40, 50 are the elements in the list, and head is pointing to the first node that is holding 10. Okay, and now you have to create a new node and keep some new value, let us say 60, and link this new node to the list, but at this point. Okay, then after linking this, what is the first node? This is the newly created node, is the first node. So you have to make it head. So furtherly, no, this node cannot be a head, because the new node created is inserted at the position of head. And how to establish this link? This new node next must consist the address of the previous, I mean the previous head. Okay, so how to realize this? Through code. This three lines code is common for anything, right? So you have to create a node by memory malloc function that allocate memory for a new node, and input a new value. First take a new value into a variable num, then this new value has to be transferred to new node data. So here I am putting a new value, right? Now what should I do? This part should hold the address of this head, so I am assigning head to the new node next, right? And what next? Now this new node is the head, so I am transmitting address of the new node to the head. So furtherly, head points to the recently created node. Okay, so this is how we insert a new node in head position. Now you can see the graphics for the same. See, this is 60 is a new node. 60 holds a value by new node, and new node became the head, and 10, 20, 30, 40, 50 is the existing list. Okay, so you have linked, you have created a new node and inserted at head position, and you made that new node as head. So this is the code you have written for this. The third way of inserting is inserting in the middle, anywhere you want. Okay, so generally for that you have to see there are different possibilities of inserting in the middle based on the user's requirement. So now I took a requirement like this. I want to insert a new element after some element. You can also insert an element before some element. You can insert an element between something. Okay, so you will be using different conditions to choose the target position where to insert. Okay, so here I am taking a concept, a condition like this. I want to insert an element after some specific, new element after some existing value. Okay, so here I took 30. After 30, I want to insert a new element. After 30, I want to insert a new element. Okay, so what should I do? So I have to traverse from head. I have to traverse from head first, because I want this address of this node, target node. Then only I can keep a new node after that, because this new node address has to be stored in this position. Okay, so I want address of this node. How could I get it? I can get it by traversing from head to the target value. So before doing everything, I have to read an element here, scanf, using a scanf statement, scanf element like that. I have to, using scanf, I have to read this element first. Okay, so after reading that value, okay, scanf %d ampersand element like that, you can use the code. And after reading that element, okay, what we supposed to do? After reading that element, I am using a loop to check whether the data in the node is matching with the element what I want. Means I have to travel towards the target element. So initially I am assigning head address to the temp. I'm taking a new pointer variable temp, and I'm assigning head address to the temp, and I'm verifying temp data is equal to element or not. So now this is the head, so 10 is the value in the temp, in the temp data is 10. Okay, and I already told you I want to insert after 30, so 10 is not equals to 30, right? Then we'll get into this, because condition is true, so we'll get into this, and temp is equal to temp next. So temp next means address of this next node. Okay, so that value is assigned to temp. Now again I am verifying temp data is not equals to element or not. So here 20 is the temp data, so 20 is not equals to 30, right? So I will get into this loop again, and I will assign the next address to the temp. So temp next means this one, because this is temp, when this is temp next is this is nothing but address of this. Okay, so what I am doing is this, I am assigning the address of third node to the temp. Now temp holds the third node's address. Now I am verifying temp data is not equals to element, but this condition is false now, because temp data is 30 here, and the value I took into element is also 30, as I told you just before. Now 30 not equals to 30 is a failure condition. When condition is failed, we will come out of the loop. Okay, right? After coming out of the loop, what is the current temp value? The current temp value is nothing but the target node, right? So now we have the address of the target node in temp, right? So what we supposed to do is I have to insert an element after the temp. Okay, right? For that, let me show you the further code for that. See this, I am reading allocating memory for a node. This is same for everything. Okay, so I am taking input into a variable num. Now that value is assigned to new node data. That means a newly created node. Okay, let us say I have given 20 as a new value to this, right? And I kept 20 in that. Then what is a new node next? New node next means the address part of the new node. Okay, so I am writing new node next is equal to temp next. Here temp pointing to this. So previously temp next value is nothing but address of this, because this connection what I am showing here using this line is already existing, previously existing. Okay, so now what is temp next? Temp next means address of this node 4. Okay, so now what I am doing is new node next is equal to temp next, means I am establishing this link, right? Till now this particular third node's next consists of a previous value only, but I want to establish this link, means new node has to be linked to the third node, right? So I am writing temp next is equal to new node, then this third new node is linked to the third node. Now I am clearing this annotation. Now see what happened is, so after the third node I have inserted a new node and linked the new node to the next node. Okay, and the third node to the new node to the fourth node, and third node to the new node. Now link is established. Now this is the link. What is the link? 10, 20, 30, 20, 40, 50 is the list. Okay, so this is how I can insert a new element in the middle wherever I want. Okay, so you can ask a question like this. So sir, if I want to insert before any node, what could I do? Okay, this is after a node. Before a node, what could you do? So before a node means this temp holds this value. This temp holds this value. Okay, so this you cannot able to make it possible holding this address in your hand. Okay, that is why whenever you want to keep an element before an element, okay, then you have to secure both address. You just keep it as temp1 and keep it as temp2 and secure both addresses, both temp1 and temp2. Then you can do this using temp1. Then otherwise previous node and current node, you can name it anyway, in whatever way you want to name, but you have to secure the previous node address for sure to insert a new element in the middle. Okay, so if the condition is before some node, you have to get the address of the before node also. Okay, so you have to write like the logic in that way. I'm not explaining that here because it would be difficult for people to understand all the things in a single instant, right? So till now we have seen inserting elements into a linked list. Okay, in the further classes we will see more operations we used to perform on list, right? Thanks for listening. If you have any queries, you can mark request in the comment section. Okay, and I will definitely reply in the comment section. If your question cannot be explained in a comment section, you can do this also. I have mentioned my mail ID in the first slide. You can mark a mail to me personally so that I can help you in a reply, right? Thank you for listening. Take care.